Hey, 8th graders. Welcome to a new week. Hope you had a great weekend and hope you're ready to rock and roll for another lesson. We're still rolling in volume, and today will be lesson 9-3, volume of spheres. Pages 257 to 260. All right. And then that's just for today, and then your independent practice will do some tomorrow. We're only going to do a few of them. I meant to grab the calculator from over there. I'll grab it in a minute. But grab your books, tear out your pages for 257 to 260. And let's get ready to rock and roll on this lesson. I want you to watch the entire video. As we go through the lesson, I want you taking notes. As I give notes, we'll show work on the side. You need to be showing work for notebook paper. On notebook paper for these. I'm trying to find my marker. Where'd you go, kiddo? Well, heaven's sakes. Give me a second, all right? So here we go. I hope all your homework is turned in. I hope that you got everything turned in, 8th graders. I'm going to get you all finished up, graded today, so you can be watching for your grades later this evening. It takes me 2 or 3 days to get all those 6th graders done, and it would really help if everybody gets them turned in at the same time and on time, because it makes it hard to get them and find them. One thing, one big request, if it's more than one sheet of paper, like this is going to have your worksheet and your notebook paper showing your work. Please do not take two pieces of paper in one picture. Just one piece of paper per picture. Try to get right on top of it like this. Take the picture, then send it. It's very difficult. Sometimes if it's slanted way out there like that or whatever, like this, some people try and take pictures with it slanted way out there. It's nearly impossible to read. So do that for me. Do a good job on taking pictures and all that good stuff. I'm going to keep your work light and fun. All right, so I know that you can get this done. Volume of spheres. We know volume is a formula. So they explore a sphere here. A sphere is a three-dimensional figure with all points the same distance from the center. There you go. It looks like a basketball. And we know that the radius of a sphere is the distance from the center to any point on the sphere. That's how we know it is a sphere. Radius is the same from every point in the center. Now, we explored that a cylinder is pi r squared times height. Agree? Because it was V equal BH. And capital B represents area of the circle of the base, area of the base, which is pi r squared. Well, a cone, we learned, is 1/3 of a cylinder. So it was 1/3 times pi r squared times height. Okay? Now, we're learning, looky here, that the height of the cylinder, of the sphere is the same height. And we know it takes two radiuses for the height. So we know that H we can now replace with 2R. Do you see that, class? We can replace it with 2R. Right there. So the formula of a sphere is going to be and it shared with us that go back up here real quick. If you were to do a similar experiment with a sphere of the same radius, you would find that the sphere fills 2/3. A cone fills 1/3 of a cylinder, and a sphere fills 2/3 of a cylinder. So therefore, that's why they have 2/3 right in front of pi r squared times height. Well, if we replace height with 2r, you can see that, because we know that to be true, h wouldn't have it's going to just be replaced with two radiuses. Look at what we can do. Well, 2/3 times 2 makes 4/3. Agree? And r squared times r to the 1, r squared times r to the first power. Remember, when you multiply variables and with exponents, you add the exponents. Do you remember that? I know we did it not too long ago. So that would be r to the third power. You would add your exponents. So r to the third power, and this is why. This is the final formula for a sphere. So let's flip it, and very good. It's nice and clean and clear. Oh, I hope that you could still see the video. I don't know if it, I looked up and it said low power. You might have seen that instead. I don't know. But I walked through this scenario if it did that. My bad. Okay, let's hustle because we're going to be low battery again, and I'll keep my eyes peeled. But right here explained that this is the formula. Do you see h anywhere? No, we do not, because we learned that the height is 2 radiuses, and 2 radiuses multiplied times 1/3 times 2/3 is 2/3, and r to the third power instead of r squared. So there it is. This is the formula for today's lesson. As you see here, this is the gives a radius of 2.1. So walking it through, you're going to have calculator. I hope you are using a calculator, Siri, or something to say 2.1 to the third power so you can get your numbers. All right, my friends? But we do write it and write underneath every time each, always start by writing the formula. Fill in pi with 3.14 times 2.1 to the third power. Then we rewrite it again with 2.1 to the third power is 9.26. Multiply, multiply, multiply. It's basically 4 times everything on top, divided all by 3. So also, I'm going to write this here. V equals 4 times pi times r to the third, all divided by 3. That's how you can also type it into your calculators. All right, my friends? So a sphere has a radius of 10 centimeters. Let's do one ourselves. Okay, here they said that they gave you diameter. So all you had to do is that radius equals 3.5 instead of 7. Watch out. Is it giving you radius or is it giving you diameter? If it's diameter, divide it by 2. Good. It's a good review. All right, one more here. Let's go with it. V equals 4 pi r to the third power, and then divide it all by 3. Boom. I said 3, but I wrote 4, sorry. Divide by 3. Next thing is plug in 4 times 3.14. Radius, r equals 10. So 10 to the third power. Good. So 4 times 3.14, and we know 10 to the third power is 1,000. Good. So we know times 1,000 is going to move this decimal 3 places. Agree? So equals 4 times 314. Got a feeling with the placeholder. 4 times 3,140. Calculator on. 4 times 3,140. Enter. 12560. 12560. A 123 comma. Volume. This was centimeters. And we know volume is cubic units. Okay? That's a practice. Good, good. Same story throughout, class. Same story. So for homework today, get rid of number 9. And let's do both of these together and then do evens. So that would be 4, 6, and 8 that you would be doing on your own. Make sure that you write your name. Write my name, Connie. At least write your first name. So when I'm looking at a picture, I can tell who you are without looking at your thing. Your, you know, where it gives you your name and whose paper I'm grading and all that. A sphere is a 3-dimensional figure with all points what from the center? Same distance. Good job. Same distance. Now, class, watch your videos. We do half our homework together. I give your instructions. Don't ever do a whole exercise without watching the video because I'm never going to make you do the whole thing. And the blank is the distance from the center of a sphere to a point on the sphere. And that is that. That is our radius. Okay? The same distance, every direction would make a sphere or basketball shape. So, we're going to be doing 4, 6, and 8. Oh, watch out on number 4. 4 says that D equals 20. So that would mean R equals 10. Did we not just do a problem on the front, that other piece of paper, with the radius of 10? Would this answer not match this answer? Of course it would. So recopy this for question number 4. All right, class, that's easy. Again, number 6 says a diameter of 2 yards. Oh, this is going to be easy because if D equals 2, R equals 1. So that would be good and easy. And number 8, a basketball has a radius of 4.7. What is its volume to the cubic inch, to the nearest cubic inch? So that means whole number. Okay, and this one says to the nearest 10th. And these up here to the nearest 10th. But number 8 says to the nearest whole number. Okay? All right. Very good. You could use this one for number 6. I like this is 6 is number 3. That's a picture of it. You just need to change inches to yards. Agree? So it's fine with me if you want to show your work. Class, there's not enough room to do the formulas. So please be sure to use notebook paper, start with the formula, and work them out. That is 3 problems to do on your own. And actually, number 4 was the problem.